Number 5, find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared, y equals 4x minus x squared, about the line x equals 3. Alrighty, we need a picture first. So if I have y equals x squared, it's going to look like that. And then if I have y equals 4x minus x squared, it is going to look like that. So this is the region in question. Actually, that should have intersected at 0, 0. Sorry about that. And we are going to reflect it about the line x equals 3, which is going to be right there. So we're going to revolve it about that line. And since I'm revolving about a vertical axis, I'm going to be using the shell method. So when I go to find the volume, I need to find where they intersect to where they intersect. Those are x values of 0 and 2. The shell method does require me to put a 2 pi out front. The next part is going to be my radius, and usually we put an x there. However, since we're moving it about the line x equals 3, the radius will be 3 minus x. And then the other part of that is going to be top minus bottom. So the top curve is the 4x minus x squared minus the bottom curve will be x squared. And if you would like to simplify that, go right ahead. It's not necessarily. Since we've got our calculator out for this one, our volume should end up equaling 33.510. If you got about a sixth of that answer, don't forget that you did need to multiply by 2 pi. Okay, problem number 6. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals 1 over x equals 1, x equals 4, about the line y equals 4. All right, let's go ahead and get a graph again. We've got y equals 1 over x, which is going to look like that. X equals 1, x equals 4. So you'll notice we've got this area going on right there. We're going to revolve it about the line y equals 4. So it's going to be up here. So we're going to revolve it about that line. Since we're revolving about a horizontal axis, we will be using the washer method. And the reason it will be washer because there's this big old gap that's going to be left in my figure after I revolve it. So what we are going to do is now we're going to have volume equals pi, because the washer method uses just pi instead of 2 pi. I'm going to go from an x value of 1 to an x value of 4. And then if you recall, we're going to do the outer radius. So if you're looking at this line right here is going to make the outside of my shape. So it will be 0, but because I'm moving it about the line y equals 4, I do have to move it down 4. And then it will be the outer radius squared minus the inner radius squared. The curve 1 over x will make the inside of my shape, so it's going to be 1 over x. And once again, I do need to move that one down 4 as well. So that's what my setup will look like. If you'd like to simplify it from there, you may. But since we get to use our calculator, we don't really need to. And when I get a final answer, it will be 32.485. Okay, problem 7. The base of a solid is bound by y equals the square root of x, y equals 0, and x equals 4. Find the volume of the solid for semicircular cross sections taken perpendicular to the y-axis. So let's go ahead and get a picture once again. We've got y equal the square root of x, y equals 0, and x equals 4. So it's going to be this shape right here. We're doing cross sections taken perpendicular to the y-axis. So if the y-axis is going this way, my cross sections will be going this way. And since my cross sections are perpendicular to the y-axis, everything does need to be in terms of y. So if I have y equals the square root of x, I do need to solve that for x. So I'm going to square both sides. So I'll get x is equal to y squared. All right, so what I want to do is I'm going to have the area equals, if you recall, we're just going to go from a y value to a y value. So definitely that first one is going to be 0. And then the second one, I notice it goes until I get to x equals 4, but x equals 4 is an x value and I need a y value. So if I put 4 into here for the x, I will get that y is equal to 2. And then my little side trip, which I'm going to take, which I usually have you guys do, we just need to find the area of my cross sections. It's a semicircle. So the area of a semicircle is 1/2 pi r squared. And so when I go to do this, I'll have 1/2 pi. My radius is going to be, well, if I'm going from here to here, again, we do right minus left. So this is going to be the right side, which is 4, minus the left side, which is y squared. But please don't forget that on this one, That would give me the whole diameter of the circle, and I really would only like the radius of the circle, so I'm going to have to divide that by 2, and then it's going to be radius squared. So that's my side trip. If you'd like to simplify it at all, you certainly may. Not necessary since it's a calculator problem, so I'm going to go from 0 to 2, and simply my area of my cross-section goes there, which is going to be 1/2 pi times the radius, which will look like that. And then once again, we can use Math 9 to get that answer. Whoops, that's a volume, sorry, not an area. There we go. And so the volume will equal 6.702.